So 2.6, number 58. We're given the quadratic x squared minus 3x minus 4. And we are asked to find the regions where this thing is entirely positive and the regions where this thing is entirely negative. It turns out that with quadratics, if you find one of the regions, the leftover region is the other. Okay? Now I'm going to go through and do this one carefully and do it both ways, but we'll see that we really only need to do one of the calculations. Okay, so to find out where this thing is entirely positive, positive means that this thing is strictly greater than 0. All right, so what are the ways that we can do this? So this thing can be factored. Okay, not everything can be factored. This thing can be factored. Since it can be factored, let's do that. Okay, so minus 4 is a 4 and a 1. This minus means that one of them is positive, one of them is negative. Or 2 and a 2, I guess. This minus 3 says the larger one must be negative. Minus 4 plus 1 is 3, so that's the way we're going to factor it out. X minus 4 x plus 1. Yeah, is greater than or equal to, greater than 0. Okay? All right. So what does this mean? For this thing to be greater than 0, both of these things must be positive. Right? We have that condition. I mean, these things multiplied together must be positive. So either both of them are positive or both of them are negative. So one of the ways we can do this is to figure out where that is the case, right? If they're both positive, means that x minus 4 is greater than 0 and x plus 1 is greater than 0. Right? We add 4 to both sides here. This is going to be x is greater than 4. We subtract 1 from both sides. This is going to be x is greater than negative 1. Okay? Now, where are both of these things true? Well, since 4 is greater than negative 1, the only way that this is satisfied is if we're greater than 4. This is satisfied anytime we're greater than negative 1, so we have to be restricted by the larger of the two. Okay, so x is greater than 4 is our condition on the positive side. If they're both negative, this is x minus 4 is less than 0, and x plus 1 is less than 0. We can add 4 to both sides. X is less than 4, and x is less than negative 1. Okay. Well, since negative 1 is less than 4, the only way to satisfy both of these conditions is for x to be less than negative 1. Okay. That's the only way we're going to satisfy both of these things. So we end up with the conditions for the positive side that x can be greater than 0 or x can be less than negative 1. Now if we graph this thing, right, if we graphed our quadratic, it would look like this. We're positive for all the x's greater than 4. We are also positive for all the x's less than negative 1. Okay. So for the positive, we have the conditions x is greater than 4 or x is less than negative 1. Let's look at the negative. Let's do it another way. Let's do it in the completing the square way. And what we're going to see is that we're going to get the complementary region. We're negative if we are between x is greater than 1, but x is less than 4. Okay, that's what we're going to find. So let's do that. Okay, we're also going to do it the completing the square way. So we're going to get x squared minus 3x minus 4 is less than 0. Okay? So, doing it the completing the square way, our b is equal to negative 3. Our b over 2 is equal to negative 3 halves. And our b over 2 squared is equal to 9 fourths. Okay? 3 times 3 is 9, 2 times 2 is 4, and negatives disappear on the squares. So we want to add that and subtract it. Minus 9 fourths, and 4 is minus 16 fourths is less than 0. Okay. This combines 9 plus 16 is 25, so this is minus 25 fourths. And if I add 25 fourths to both sides, I will remove it from this side. Okay. And I will get 25 fourths on the other side. Over here, this is our perfect square. This is x minus our 3 halves squared. Okay? So, what we're going to get, right, this is this, this is this. If I add 25 fourths to both sides, this will cancel here, leaving us with our square. And I'm going to write my square back up top because I think I'm going to need the room. Okay. This gives x minus 3 halves squared is less than 25 fourths. Okay, so now we want to take a square root. But now remember, with a square root, we're going to have issues because we have to allow for both the positive and the negative. Now the positive, the square root of this squared is just the thing inside. X minus 3 halves is less than the positive square root of 25 fourths. But the square root of 25 is 5. The square root of 4 is 2. Okay. So now if we add 3 halves to both sides, it'll cancel over here, leaving x less than 5 plus 3 is 8 halves, but 8 halves is, of course, 4. So x is less than 4 is on the positive side. On the negative, we're going to have x minus 3 halves is less than the negative of the square root of 25 fourths. Again, the square root of 25 is 5, and the square root of 4 is 2. So now when I add the 3 halves to both sides, x is going to be, oops, shit. That has to be greater than, right? Because of the negative sign, we choose the negative root and we flip the inequality. I've docked myself a point there. Okay, so x has to be greater than negative 5 plus 3 is negative 2, but negative 2 over 2 is the same thing as negative 1. So x has to be less than 4, greater than negative 1. The only way that happens is if x is between negative 1 and 4. Okay, and that's exactly the endpoints we got for the other one. So if we're not greater than 4 or less than negative 1, we have to be between. There we go. And remember, on the negative side, don't forget to flip the inequality. We really need to do that. Otherwise, you just get nonsense, like you see.